Welcome everybody to today's webinar. We're based in Galway in Ireland, our EMEA headquarters for SmartBear, and we're running the webinar from our studio here today. Myself, Ronan Trainer, and Joseph Joyce, and we're talking about how we're going to leverage virtual services in microservice environments. So the idea is to try and reduce complexity, eliminate downtime using service virtualization.
Absolutely, and you've already done the introduction. So, like Ronan said, Joe's my name, and we're both working on the API product engineering team here in Galway. A small bit of housekeeping. First of all, the session is being recorded, so anyone who joins will be able to get a recording of this maybe in about, I think, just under 24 hours. Within the next 24 hours, you'll have a recording of the session if you want to review it and go over some of the nuggets of wisdom that we'll be discussing. If you have any questions as you go through, I can see some people are posting in the chat box at the moment, just to let us know they can hear us. So thanks for that. If you do have any kind of technical questions or questions about any of the content, then definitely if you could just post it in the Q&A box. So there's a separate icon there in the middle of your Zoom bar for Q&A. So it'd be really helpful if you could post it in there. It's just a little bit easier for us to keep track of your questions. Absolutely,
and follow up if there's any questions that we can't address in today's webinar, because we've quite a large attendance here today.
Yep.
Perfect. We also have two polls to run as well, Joe. So we might, after the introduction, run one of them, and then we'll run one at the end as well. And this is just a way for you guys to give a little bit of feedback. And if you want to contact us with relation to setting up specific tailored sessions for your teams, then this is the best way to let us know that.
Absolutely. So starting off, just a very simple agenda. Just 3 items.
Simple is good, Joe.
Simple is good. Keep it simple. We'll start off with a quick introduction of SmartBear, who we are, what we do. Then we'll talk about some of the important concepts behind the session today, most of which have kind of been mined from our State of the API report. We've run a couple of webinars on that recently, kind of going through some of the results and talking about some of the trends and challenges that teams are identifying, but specifically around microservices in this session. And then we'll take a quick look at some of our tools to see how you could kind of practically apply some of those concepts that we'll talk about. And that'll be it. So without further ado, we'll kick off with the introduction. So just a few introductory slides just to get out of the way first of all. So myself and Ronan work for SmartBear. SmartBear have been around since 2009, quite a global footprint, 11 global offices. So we're in Galway on the west of Ireland in our EMEA office. The global headquarters are in Boston. But we have several other offices around the globe. Millions of users of our tools, thousands and thousands of customers, over 500 employees. And essentially what SmartBear do is we provide software tools to development and testing teams to help them improve the quality of their software. And it's as simple as that, really.
Yeah, and worth noting that we have our Swagger Hub development team here. So if any of you on the call are using open API specification for you to define your APIs from a design and development perspective, the Swagger Hub development team sit in Galway here as well entirely. So
if anyone's looking for autographs,
yes,
from the development team, just let us know and we can ask them. If you fax us your OAS specifications, we can get some of the guys to sign them.
Yeah, that fax machine is still running, isn't it?
It is. I hope it is.
Excellent.
So yeah, that's it. As Ronan said, kind of one of SmartBear's big contributions would have been the Open API specification, which is formerly Swagger, now OAS. There are the Swagger open source tools, and then we'll talk a little bit more about the specific tools in a second, but then also SOAP UI is an open source API testing tool. So they'd probably be maybe two tools that would kind of help people get to know us. Always nice to get a bit of recognition. And here's some of the recognition that SmartBear has received from a couple of different organizations like Gartner and Forrester over the last couple of years. So you can see in Gartner's famous Magic Quadrant there on the left-hand side, we were recently identified as a leader based on our vision for embedding intelligent automation throughout the delivery pipeline. Forrester identified us as a strong performer based on our superior testing capabilities and API, strong TDD and BDD offerings. And Gartner, again, just acknowledging that we've made a strong commitment to open source by supporting and contributing to major projects, as I mentioned earlier, like Selenium, Swagger, and SoapUI. So yeah, just a little bit of industry recognition. So to talk a little bit more about what SmartBear actually, the tools that we make and the tools that we support. So we've got tools that fit in pretty much across all points, or most of the points in your SDLC. From a design point of view, the tool that we'll be looking at today is Swagger Hub. So Swagger Hub, as we mentioned, is a tool for kind of collaborating on and managing API definitions and specifications. So that's obviously kind of important when it comes to microservices. But then from a design point of view, we also have HipTest and Zephyr. So then we have the section of the slide here called create. And in this case, when we say create, what we're talking about, actually kind of creating artifacts or assets that you could use for your testing and your development. So you've got tools like Collaborator and Test Left, but kind of on the API side of things and specifically on the virtualization side of things, there's also ServiceV Pro. And what you're creating with ServiceV Pro are basically virtual versions of microservices that aren't actually maybe they aren't actually developed yet. Which, if you're working in a microservice architecture like we're talking about today, the ability to spin up a virtual version of a microservice before it's actually developed can be pretty powerful.
Yeah, and exactly, even taking a step back, we're not talking about just creating a stub or a mock. And we're talking about designing our API, building out our methods and our resource paths. And before we actually generate our client and server code, which we can do in Swagger Hub, which is going to remove a lot of that work for us. I suppose, the skeleton of the code can be built out using CodeGen, which is one of the part of the Swagger framework of tools. We can take, from the design stage and generate a dynamic, a virtual API or a dynamic mock. And then we can use that in our different automation frameworks, our pipelines. We can have our virtual APIs stand in for those services that are not developed yet. So it's critical when we're in an agile world where it's all about speed of release, speed of testing, automation. It fits in there very well.
Absolutely. So yeah, they'll probably be the two main tools that we'll focus on during today's session. But as you can see, we have a few others from a testing point of view. SoapUI Pro and Test Complete would probably be two of our most popular tools. SoapUI Pro for API functional testing, Test Complete for UI functional testing. On the deployment side, they're just obviously some platforms that we integrate with, like Chef, AWS, and Kubernetes. And then we have AlertSite for monitoring your services once they're deployed. So yeah, pretty much a tool for all occasions.
Absolutely, right from design through to post-deployment monitoring.
Absolutely. So on to the second part of our agenda, which is concepts. So first of all, maybe a little, maybe kind of an introduction for anyone who might not have attended the State of API survey sessions that we've run before. So this was basically, the State of API survey is a survey that we ran amongst multiple organizations and hundreds of different team members who are working on API projects or in the API industry. And the idea is that this the survey would kind of give us an insight into trends and challenges and just kind of common themes that are popping up amongst teams that are working on API projects. So the first slide here is giving you an idea of the type of people that we talk to and the type of roles that we talk to. So kind of straight up at the top, kind of taking the biggest chunk, you have like an application developer. So maybe someone who's getting hands-on at the coalface, writing the code for these applications and these APIs. And what I think is interesting then is it's probably the second most frequent type of role that we spoke to was an architect. So maybe someone who's kind of a little bit, has a kind of more bird's eye view of solutions. Maybe isn't necessarily writing the code for the solutions, but is involved in the planning and the design would maybe be more interested in a tool like Swagger Hub that's going to help you get design consistency across all of your APIs. Maybe they're less concerned about implementation.
And exactly, like, they're interested in things like, workflows, DevOps, continuous integration pipelines, automating workflows, and having collaboration across the organization, throughout the API design or the API software development lifecycle.
Exactly. And, the role of the architect is particularly important when it comes to, to microservices, because if you're, there obviously are advantages to splitting up your functionality into kind of smaller chunks and maybe smaller services or blocks of code. But then the other side of that is that you need to have someone with that bird's eye view who is going to understand how all of these different chunks and all of these different pieces of functionality interact with each other as well. So yeah, and then as you move down, again, there's a kind of varied mix of roles. You've got web developers, you've got DevOps engineers, BAs, product managers, documentation writers, performance engineers. So some more than others, but obviously everybody, pretty much is involved in the API process to some degree.
So this is essentially the people who were interviewed for this State of the API survey, and that are very relevant.
Oh yeah, absolutely.
We're not heading down to the local bakery and asking them about APIs.
Oh, you never know. There might be some insights there. Go down to the local craft brewery and ask them about IPAs.
Yes, we could.
Yeah. It might be a more fun discussion. The next slide then is a little bit on. We tried to get an idea of the standards that people were using for defining their APIs, and luckily for SmartBear, Swagger and OpenAPI was the most common and the most commonly used. So obviously Swagger and OpenAPI is specific to REST services. So this is kind of an indication that, that's kind of the way the industry is going, that if you're going to develop an API, or if you're going to have an API, function to your business, then, and if you want these APIs to kind of play well with other teams and to be able to integrate with other organizations, then REST seems to be, the kind of architectural standard. And then for defining the APIs, obviously Swagger and OpenAPI is the one to use. You've still got some maybe older, kind of more legacy types of standards like WSDL, WADL, RAML. 15% not using any standard at all. So I'm always curious when I see entries like that in the results to know, okay, if you're not using an API standard at all, are there no definitions? Is it just a case of, maybe there's a business document describing what the API needs to do, and the code is written, and that's it. It's kind of released out into the wild. And maybe not in the Q&A box, but even in the chat box, if people kind of want, if there's, maybe anyone listening now aren't using a particular API standard, we're always interested to find out maybe what your approach actually does look like. So certainly let us know. So getting more towards the microservices side of things here. So we asked the people taking the survey, in your opinion, which of these technology areas do you expect will drive the most API growth in the next 2 years? And microservices came out on top, 73% of the vote. So yeah, 73% of respondents believe microservices will have the greatest impact on API growth, and up from only 20% of respondents in 2016. So quite a jump. And I think the important thing to understand here, and like this is something that comes up all the time, internal conversations and conversations with other teams, it's just, the difference between APIs and microservices, and, kind of how they relate to one another. And I think the best kind of visualization that I've seen of it, or the best kind of simple explanation I've seen, is that, so an organization might have their tools and their platforms built up of microservices. So within, if you imagine a border, and the border is your organization, and within that you have 20 microservices, and these are like smaller little blocks. And so they're your microservices, and that's the functionality. And some of them are internal, but then some of them might be external. So you might expose some of these microservices either to other organizations, other companies, other teams. And to expose a microservice, sometimes a good way to do that is using an API. So in my view, the API is an interface to the microservice. So the microservice is, the actual implementation of what you're exposing through the API. So they're kind of interlinked, not exactly the same thing, but if you have an API or if you have a microservice and you want to make that microservice kind of visible or usable by a team outside of your organization, then an API is usually a good way to do that, because you don't necessarily want to expose too much about your kind of underlying architecture in your own organization. A good thing about an API is that it might just be as simple as providing a team with an endpoint, a URL or a URI, and that's all they need to kind of make the most out of the functionality that you already have developed. But kind of going back to the slide then, this was identified, so microservices were identified as the area that people expect will drive the most API growth in the next 2 years, which makes sense, because if more software companies are adopting this microservice architecture and they want to start kind of capitalizing on the microservice functionality, they're going to need APIs to do that. So it makes sense that the growth of microservices would drive the growth of APIs. So this is just, I suppose, kind of another visualization of what we just talked about. Microservices have changed the way that organizations work. And what we're visualizing here is, saying that pie chart up on the top of the slide. And we asked teams how many teams were working with just internal microservices, how many were working with external microservices only, or APIs only, and how many were internal and external. And the vast majority, and 76%, were working with both internal and external APIs. So you can take that to mean they're integrating with, you might be using a microservice that's owned by another team in your own organization, in terms of an internal API that you might use. And then in terms of an external API you might use, you're making use of a microservice that's being developed by another company altogether. So a mix of internal and external.
Yeah, or potentially exposing your own services to external consumers.
Yep, exactly. So the majority of services are built for internal interoperating systems, and most teams develop and use a combination of internal and external APIs. I suppose in terms of the kind of the other kind of graph on the bottom of the slide there is in terms of the reasons why teams are adopting internal and external APIs. You've got benefits like reducing development time, reducing development cost, reducing infrastructure overhead, to help with regression testing. So there's a whole host of benefits to working with microservices and APIs, whether they're internal or external, and some of them are visualized here. So yeah, so maybe we should have put this slide at the start, just to kind of before I feel like I've said microservices about 50 times. But yeah, we kind of spoke a little bit about kind of the explanation of what they are. So hopefully we're all kind of on the same page. But if not, I suppose the contrast that you normally hear in conversations about microservices is that the microservice architecture is like, a step away from a monolithic application architecture. So like a monolithic application architecture, if you imagine it maybe in terms of just something as simple as like a file. So in a monolithic application, you might have a lot of functionality and a lot of business functionality contained in one code file, for example, or one kind of block of code. Whereas microservices, the idea is that you're breaking that out and you're kind of modularizing your code a little bit, where you're keeping it fairly, I think atomic is the word that you'd use, but that each block of each service really is just going to do one thing and do one thing really well. So you might have one kind of business functionality, and that's one microservice, and that could be something like, update inventory to kind of, move a little bit towards the example we'll be talking about later on. Like when we show the demo, the kind of story that we're going to tell is, if you imagine that you're working on an ERP platform, that's the platform that you're developing, so an enterprise resource planning platform. So if you can imagine within that umbrella of like an ERP system, you're going to have potentially hundreds of different kind of functions and services. And with a microservice architecture, you'd split them up. So each function is one microservice. So you might have one for, update inventory item. You might have another one for retrieve inventory information. You might have one for place an order, that type of thing. And that's really, in my opinion, as kind of simple as it is with microservices, that you're keeping things to one specific job, which makes it easier for internal and external teams to call on that functionality without having to call on the entire application. What do you think, Ronan? Does that?
Yeah, absolutely. There's a couple of questions coming through. Wondering
am I posing more questions?
No, wondering is the state of API webinar or got to do with service virtualization. But I suppose this leads on from the state of API webinar that we ran. We're just going over a couple of things, and then we're going to get into microservices and definitely service virtualization. So,
are you saying that people want to see more virtualization?
I think so.
That's good. That's good news. Excellent. Good. This is more just like a preamble up to the service virtualization. We can talk much more about that in a second. But I suppose, okay, so if we start moving the discussion more towards our tools and more towards like kind of getting hands-on the technical side, like ServiceV is SmartBear's virtualization tool. And, for someone who hasn't, myself and Ronan would demo the tool a lot, every day to different teams. So we're always explaining why virtualization is important, especially for microservices. And I just think this kind of a preamble and this kind of, if we establish kind of, why microservices are important, then it's much easier to, see the benefit of something like ServiceV or virtualization. So yeah, we'll take the feedback there. So maybe that's enough on microservices for now. And this is just some examples of service-driven companies. So these are basically platforms that provide deep functionality at low cost. And you've got some examples there like Salesforce, Pusher, Twilio, Stripe, Braintree. So pretty much any, kind of more modern software company is kind of structuring themselves. Even Amazon are a good example of that, where they've broken down the functionality of their offerings to different services. So you've got like, AWS, you've got EC2, you've got gateways, you've got Lambda, they've got a host of different services. So, you're not just buying one thing if you are paying Amazon money. You could potentially, break it down to specifically what it is that you need. So that would be like a service-driven company. Now, the moment that we've all been waiting for. We get a little bit more hands-on with some of the SmartBear tools now to show kind of example of how you might use and why you might use service virtualization. So the scenario that I mentioned a little bit earlier on, if you imagine that we're working on an ERP system or an ERP platform, so maybe we have dozens and dozens of microservices that build up our ERP system, and we expose these through APIs, and we have multiple integrators who are working with different parts of our ERP system. So maybe currently we have version 1.00 of our inventory API is in production, so teams are working with it, they're integrating with it, they know it's working, but we need to add new functionality that's coming up in version 1.1.0. So, it's good practice for a service-driven company to obviously give teams that are integrating with them a lot of notice that a change is coming, give them time to build new tests for their own applications, maybe develop new client SDKs, front-end applications. And virtualization is a good way of speeding this process along. So allowing integrators to start building their tests a lot quicker. And kind of minimizing downtime for your integrators and keeping everybody in the loop. So bear with me 1 second and just close this. So we should all be looking at Swagger Hub. So Swagger Hub, as we mentioned earlier on, is our platform for designing and defining APIs. So, if you're an API-driven organization, then it's good practice to have, good quality API definitions and API documentation so that your integrators are going to be able to understand exactly what your APIs do. And then from an architecture point of view, definitions are going to keep functionality consistent. So you might have an API specification. It's like a blueprint of what your API is going to do. And you can pass this off to test teams and development teams, and you're going to make sure that everybody's working on the same functionality. So to kind of tie this into the example that we talked about earlier. So let's say I've got version 1 of my inventory API here. And it's a pretty simple API. All this has at the moment is a post request. And so this post function is going to allow integrators to add a new inventory item. So in this hypothetical scenario, this, we've released this version of the API. This is a published specification, which means the actual code has been written for that post function, and integrators are able to pull that into their own applications and update our inventory system using the API that's defined here.
And using the integrations, we can push our code and our API definition to our API gateway as well.
Exactly, yeah. So something like Swagger Hub has integrations with a couple of different systems, but one of the useful ones is that it integrates with Amazon Gateway, which means that once a definition or once an API kind of under the hood is written and developed, you can push all those assets up to an API gateway so that your production code is kind of matching up to what you have in your definitions. So a gateway integration is pretty useful when it comes to keeping things consistent.
So essentially, Swagger Hub is your single source of truth for your API documentation.
Exactly.
But as part of a workflow, you could generate your client SDK and your server code and your API definition, auto-sync that with a source control management tool, and then either pull that code into a pipeline or push it to a gateway where your developers are going to start coding out the business logic behind the API.
Exactly. Yeah. Swagger Hub makes the most sense when you're kind of picturing how you'd use it with other tools in your workflow. So like you said, it makes sense kind of at the start of that process, and you can integrate it with other tools along the way. And so like to take it back to this example and to move more towards virtualization. Okay, so if this post request has already been implemented, obviously the functionality is there. We don't necessarily need to, virtualize that. But if I go to version 1.1 of this API, and let's say we want to add in a new function, get inventory. So for the post request, users are able to update the inventory list. And now we want to give integrators the ability to pull a list of inventory items. Okay, so from a Swagger Hub point of view, you can see I've got that get method or get operation described here in my YAML. So again, I'm not sure if anybody's familiar with OAS or how the YAML syntax looks, but you're specifying things like a summary of the operation, an idea of what type of data the operation produces, JSON in this case, an example of the parameters that an integrator will need to pass to the call, and also some sample responses as well. So the idea is with a specification like this is that you're going to define exactly what your operations are going to do before they're implemented. So in this example, we have defined the new functionality that we want for our API. And now it's time for our developers to actually start implementing that and writing the code. So let's say we hand this off to our development team. But at the same time, we want to give our integrators notice, there's a new functionality coming. Maybe it's going to be a break and change for what you have integrating with us at the moment. Here's a new endpoint, or here's something that you can use to start building functional tests, or developing a new client or a new front end just to make sure that this new request is going to work. And that's where virtualization comes into the picture. So we were looking at Swagger Hub there. So Swagger Hub is, obviously, as we said, our design, definition, documentation platform. So virtualization then from a SmartBear tool point of view is handled by ServiceV Pro. And like I said, ServiceV Pro, it's got a couple of benefits. So one of them would be, if you want to create your own version of a third-party system that you use, and you can use that to isolate a system that you're testing. But in this particular example, the benefit of virtualization is that we can create a virtual version of that new inventory functionality and deploy it either using Virt Server or Amazon Gateway. And we can give that endpoint to our integrators and say, here you go, start sending your new calls to this endpoint, and you're going to have that new functionality that we know isn't actually developed yet. But because our virtual version is kind of dynamic and is going to behave as it is described, from the consumer point of view, they're interacting with what the API is actually going to eventually do.
Exactly. They don't need to be aware that there's a virtual service built for the new methods that we added into our specification.
That's it, yeah. Like, this is all something that will kind of go on behind the scenes. You don't even necessarily, you wouldn't even necessarily need to specify this is a virtualized version or a virtual service, because with ServiceV, it kind of moves beyond like a static mock or a stub or something like that, and it's a bit more dynamic. And so, as with most of the tools, or all of the tools in Ready API, you can use a Swagger definition as like an input. So what I've done here is I created a new virtual service, and I created it from a Swagger definition. So I just pulled in this Swagger file that I was working on here that has my new definition described in there. And what I ended up with is this inventory virtual service. So a virtual service in ServiceV Pro is built up of different virtual actions. So you can see here we have this post request, which is obviously we already had that developed, so we don't even necessarily need that post request. But what's important for us to virtualize here is the GET request. So this GET request is what we have now described in our Swagger file. Maybe our developers are still working on actually implementing it. But in the meantime, we can use this virtual version to pretty much mimic what that API is eventually going to do once it's fully developed. So on the left-hand side of your virtual action, you've got the resource path and the type of method that's being used. On the right-hand side, then, you've got examples of outgoing messages. And this is also pulled from my Swagger file. So you can see you've got like a sample JSON response here with a 200 code. And you've got a sample 400 code as well for a bad request. But you can add multiple responses to a virtual action in ServiceV. And that's kind of where the real advantage of the tool comes in terms of virtualizing something a little bit more realistic or dynamic. So whereas, if you're building your own stubs or your mocks, maybe there's only kind of so much behavior that you'd be able to simulate. With ServiceV, you can have multiple outgoing responses possible for a virtual service, but you've also got this dispatch style drop down here. And the dispatch style it's a pretty important feature, because this is basically how you tell your virtual service how to behave and how to handle certain inputs and calls. And you can send them in sequence, you can send them at random, but and that's fine if you're simulating a simple action or a simple operation. But if you want to simulate something a little bit more realistic, you can do parameter matching. You can do query matching. You could write an XPath expression if your incoming request contains XML. And you can also even write a script. So if you want to perform some more complex validation, or again, get your virtual service to behave as close to the real service as possible, you can set that up using Groovy script or JavaScript. So you can end up with something, it's virtual. Technically, it's a virtual service. There's no actual microservice running underneath this, but your virtual service in ServiceV is going to behave essentially as your microservice eventually will.
Yeah, absolutely. And like some questions coming through in regard to mocking. So mocking for me is, or stubbing, is where we have a static response returned, right? So we're just returning a static response. Generally, we're going to script something up. I think the thing with ServiceV is we can build logic into it. So, if I'm submitting, for example, a inventory ID and some other criteria, then I can control based on some of those parameters, or that, what response we're going to return. And we can also going to take it to the next level. So, for example, based on certain request information, we can dynamically build queries to pull information from a test database and return that information in our responses as well. So to the naked eye, that virtual service is working in a similar way to the actual API itself, but it's available now. So when you think about what Joe's doing here, where we have version 1 of an API and then we're moving to version 1.5, we're adding new functionality, we can essentially have our tests running against our live service, right? Our version 1 of it, and we can have certain methods and resource paths pointing to our mocked versions of that as well.
Exactly, yeah. Exactly. And there's, as you said, with virtualization and with microservices, and in this example, you might have some functionality is already there, it's already implemented, and some might need this virtual service. And for that, you've got like your routing options here. So if you wanted to, for certain requests, you route to the real endpoint, your real ERP API. But then for this new functionality, you maybe would want to route to ServiceV or keep that within the virtual environment. So it's pretty easy to, to kind of keep that change behind the scenes from a user point of view. So you may have seen that lovely painting up on screen a second ago. That was just my browser. It's the Google Arts and Culture plugin, which I would highly recommend if anyone's wondering. It generates a new piece of artwork in your browser every day. So little plug there. But what I'm doing here basically is just showing how you can start using this URL. So right now I'm working locally. So this new virtualized service is just sitting at my local host port 8088 behind this resource path. So I can use my browser as the client here. And if I send this request, you can see I'm getting an example response back. And obviously this is a pretty simple example. So this dispatch style is sent to sequence, and one response is a list of inventory. So if I send it again, I'm going to get an error code. And that's how the sequence response works. But you can have, again, like I said, multiple outgoing responses and a different dispatch style if you want. In terms of bringing all this kind of closer to like a production environment, so again, if we scale up this idea and we want to, obviously a local host endpoint isn't very useful to all of our external integrators, and it's going to be pretty hard for them to start using this. What you can do is you can bring in a tool called virtServer. So virtServer is another SmartBear tool, and essentially it's a tool that we use to deploy these virtual services and to kind of bring them closer into like a production environment. So right now this is all local. If I go up to the project level, you can see here's my local virtual services. And I have virtServer installed on this laptop I'm working on now, so that's virtServer running away in the background. Once you have an instance of virtServer running, you're going to see a new URL and a new instance of virtServer here. So if I wanted to deploy this new virtual service and make it available to my integrators, it's just a drag and drop, hit play again, and now that virtual service is running here at this endpoint. And all that means is instead of using my local host, I can use that public endpoint. And again, if you want to change that domain name or to bring in the gateway example as well, it is possible for you to take that endpoint and an AWS gateway, for example, you could configure your gateway to route any of these new requests or requests going to this new functionality are going to be routed to this endpoint. So again, you can potentially hide all of that from the end user and from your integrators. So if you're using the gateway, all your API requests will go on there anyway. You can configure your gateway to route these any new requests for this new functionality to go to the virtualized service. And again, you're keeping that kind of, you're keeping that under the hood, so your integrators don't necessarily, they're not going to notice any downtime. They're going to have time to build. Potentially, they can build new test cases against this new functionality. They can make changes that they might need to make to their client applications if they need, if they need new front end functionality to handle this new GET request. They can build that using this endpoint or using this virtualized request as well. And all of this basically, like, I was talking to a team recently who said that, they were legally required to give their integrators, I think, a year's notice of like potentially breaking changes in the API. So one whole year, they need to let people know, in 365 days, we're going to go live with this new functionality. And just so you know, it might have some negative effects on your current integration. So in that example, you could, at the start of that year, you could send out those emails and say, look, this change is coming down the line. You're going to have a whole year with this virtualized version of a microservice that you can use to change your front ends, change your test cases. And you've got a whole year of testing and development. And then, after 365 days, flip a switch and they move towards the real, well, not that is the real microservice, but using something like ServiceV, you've had a whole year of a virtualized microservice that essentially, as you can see, you could set up to behave nearly exactly the same way as the real microservice would.
Okay, just a couple of questions I'm going to answer live, Joe, here while we're doing. So, do I need to use VirtServer license to deploy the mock API to this URL other than localhost? So, essentially, ServiceV allows me to design a virtual service, right, from a definition or from recorded traffic or from other methods. Once that virtual service is designed, we build a business logic into it, right? We connect it to our test data. It depends on the complexity we want to get to. If we want to share that virtual service, we can deploy it on the VirtServer. That can run, on a VM. It can run on a server in our network. We could spin it up in a Docker container as part of a CI pipeline. So in ServiceV, I'm going to design these services. And then once they're built, I can fit them into any workflow I want, really. Okay, so what I would probably do is if I was setting up my project, building services and functional tests, I'd probably push everything using the native integration ready API to GitHub and have everything there. Many different ways to do it. So essentially, ServiceV will allow me to build the services and run them locally, and then VirtServer is where I can share my virtual services to in a number of different ways, right? And then they're accessible to all the systems and users that need to interact with it. So for example, once there's a virtual API in VirtServer, I can pop open my UI application. Maybe I'm consuming an API that's not ready yet. And my team comes to me and say, we've hosted this virtual API on VirtServer. Here's a link to it. Now I can consume that virtual service and run my end-to-end UI test, for example.
That's it.
So I hope that answers a couple of questions.
Yeah, let's see. There's a few. What's the name of that plugin again? I might have missed when that one came in.
Question: Is this tool free along with Swagger Hub? No, ServiceV is a licensed tool. There is a base version of it available, but you'll be limited on functionality there. So.
I see Constantinos asked, where does that run? If we're talking about there was two environments there basically. This virtual service was running locally. It's just running, it was kind of only internally visible. This virtual service, it's still, I suppose technically it's still running on my laptop that I have here, but my laptop is now the host. It's now a host that's externally visible as well. So they're both, both those services that we looked at there were running on my laptop, but when you're just using ServiceV, you can only have a local host URL. If you're using VirtServer, then your laptop becomes, a VirtServer that you can use to deploy.
Yeah, and if you think about, your version 1 and your version 1.5, right, of this API. So essentially, I may have virtualized this before, right? Now we've built out the API, so we have version 1 available. But essentially what I could do is I could build a mock with all those resource paths and methods. For the part that's actually coded, when a request comes to that mock, I can route it to the API gateway where the actual API is. So we're interacting with the live API. For the piece that's not built yet, if a request comes in, then that response has been generated by a virtual API. So using routing and recording, we can interact with both existing live services and virtual services and switch that around as we need it as well. There's a question as well about parameter matching. So you can get some good examples on our documentation site, but essentially with a parameter dispatch method, I could, depending on a path, a query parameter, a path ID or something like path parameter, query parameter, or a header value coming through, I can very quickly set up rules, and you can see the screen Joe has up now. And we can point and click and create rules to return a certain response based on certain criteria in the request as well.
Yeah, so this is kind of the UI, or the drop downs are empty here because we're looking at a GET request, and there's no, I don't think there's any parameters in this particular GET request. Oh, there are. But yeah, I suppose basically leaving this example aside, you know, if you had a parameter called ID, and you could say if ID equals 5, then send response 1, 2, however many were there. And as you saw a second ago, you could kind of build these out as well. So you could kind of create more detailed rules. So if parameter ID is 5, if parameter password is, you know, password 1, and you can build that out. So that's essentially how parameter matching works. So it looks like Sergey recognizes some of the functionality from SoapUI. So yeah, it does. In SoapUI open source, there's kind of a basic enough version of this ServiceV virtualization possible. So yeah, it's built on that, Sergey, but it kind of scales it up as well, because the kind of virt server side of things isn't available on SoapUI Pro. So it will be slightly more time consuming to, you know, if you're going to start deploying your virtual services created in SoapUI open source to external testers and developers, it's not quite as straightforward as it would be using ServiceV Pro. But you're right, there are some similar functionalities between the two. Yeah, there's a few requests coming in for links to the online documentation. So bear with me 1 second, and what I'll do is, just so everyone can see it, I'll post a link.
I can do that if you want to.
I don't mind, because I think we're pretty much, in terms of a demo perspective, that's essentially everything that I wanted to show. You know, we've talked about, we kind of walked through our example where we started off with, you know, we started off with our Swagger specification. We had version 1 and version 1.1. And the idea here is that, you know, we want to notify our integrators, okay, version 1.1 is coming. The change, you know, in this simple example, there's only one new operation, but we want to give external teams the chance to see how their own applications are going to be affected by the change. And using ServiceV and virt server, we can do that and kind of give external teams time to see how that's going to be affected before we've actually rolled out the real change, as it were. Now, obviously, this is a pretty simple example, and, you know, there's a lot more complexity involved if you were to kind of scale this up and have multiple services, multiple instances of virt server. It would all depend on your own industry and the requirements on your team, but this is essentially the kind of the foundation of how all of that would work.
Yeah, I'm just going to launch a poll with regard to ServiceV. So this is, you know, with regard to the webinars we run, you know, we've got lots of people, hundreds of people on this one. In general, you know, if you want to get into the weeds and get into, you know, a little bit more detailed talk on service virtualization, then it's best to kind of set up a call with us directly, where we can kind of understand your requirements and your needs for virtualization and tailor a session around that. I think, you know, with regard to, and my usage of Swagger Hub as well, is that, you know, as Joe showed with version 1 and version 1.5, you know, I've created a virtual service from my open API specification, or my API definition. I've fed back to the team that we need to develop version 1.5 of that. In Ready API, then what I can do is I can directly import and refactor that API definition to add any new methods that have been, you know, are additional in 1.5. Then we can quickly build responses for those methods and resource paths. So essentially, you know, what we're getting to is that you can use ServiceV, use Swagger Hub, and use the integrations to create, you know, iterative development of your APIs. And then you can manage your documentation and your versioning in Swagger Hub and create those virtual assets in ServiceV. So just going to keep an eye on the question. Thanks for answering the poll. Now, I'm just going to launch one more as the final one. So we're just wondering what kind of tools you're using for it at the moment and if it's becoming critical to your business. So there's a question through about how will monitoring work with an existing complex applications like SOAP-based web services. So if you're talking about the alert site, which is our tool for API monitoring, it's essentially a synthetic monitoring tool that we can spin up from a SOAP UI functional test. And then we can hit that API from various different locations around the world at specific intervals to ensure that the API is up and it's correct, as in returning the correct responses, and it's returning and responding within the SLAs that we have. So that's where alert side would fit into this if you want to monitor the critical APIs within your organization. So with regard to ServiceV and Vert servers, there's a couple of questions coming through. Support Windows, Mac OS, and Linux environments. Vert server is a standalone application that will again run in any of those environments as well. And is this tool provide SSL TLS protocol? Yes, is the answer to that. And again, you can get more more information on that on our site for documentation. And can you export your tests, or would you use virtual service results inputs?
I think I just typed the answer to that one.
Okay, yeah, it's gone. It's just disappeared from my screen here. So
don't worry about it. Yeah, no, I was just saying there that, you know, another use case for this, like, or not another use case, but I suppose to talk about this from the side of like the integrators, you know, you could take your virtual service endpoint here, for example, and if you were lucky enough to be using SOAP UI Pro as your API functional testing tool, you could just put in your endpoints here, or put in your virtual endpoints in your functional tests and build your tests around them. And the idea would be, you know, if you talk about an absolutely ideal scenario, if you're using a definition-driven approach and you have a, you know, detailed API contract that describes how the API is going to behave, and if you use that as the artifact for all your development and all your testing, then, and you also use it to build your virtual service. If a team are testing against your virtual service, and then you use the same definition to build your actual service, then in theory their tests should pass the same as they were against the virtual service when they're eventually testing the real service, in an ideal scenario.
Yeah, absolutely. Question is the configuration text format, making it easy to store in Git. So all within SOAP UI. So if you've used SOAP UI open source originally, your project is saved as a single XML file. In Ready API, you can create a composite project. So that basically breaks up all your functional tests, performance tests, any mocks into a directory-like structure that you can then sync using our native integration with Git. Okay, so that would work if you have, you know, multiple team members working on the same project, and you have your single source of truth for all that project information.
I'm breaking the rules here, and I'm having a look in the chat because some people are posting their questions in the chat. But Michael asked, how does license and deployment of virtualization work on containers? So amongst our various integrations that we have in Ready API, we do have a Docker image of Vert server. So it's pretty straightforward. Is the short answer to that question, is that we've already put together the Docker file and the Docker images up on Docker Hub. That basically lets you run and deploy these virtual services on an instance of Vert server in a container. So even kind of across Ready API, obviously containers are becoming a pretty big part of companies' architecture. So a lot of the functional testing tool, SOAP UI Pro, we have a Docker image for that, and we have a Docker image for ServiceV Pro as well. So it's possible to run a lot of these assets and use them in containers, as opposed to just in a more traditional environment, like on a physical machine or a VM. Someone has just joined and asked if they can be added for the next session. They've joined too late, can't get everything clearly. I think even if you joined late, you should still get the recording.
Mm-hmm.
So that's not a problem.
Yeah, absolutely.
Full recording of the session, even if you have registered and joined late. You'll be able to listen to us chatting away.
Yeah, absolutely. Can you consume call ServiceV inventory tests and SoapUI Pro test steps? Absolutely. So any tests I can run against. So if you've used SoapUI Pro before, I can create my end-to-end API test. So say, for example, log in, search for an item, buy an item, log out. When we log in, we get a session ID. We need to pass that to our search step in order to search for an item. Okay, so we can pass values between different API test steps. So what about if log in, search, buy? So maybe we haven't built out the functionality to buy an item, right? So we want to virtualize it. So we can build some logic in ServiceV. We can build out our responses, maybe connected to our test data, and based on certain criteria, create dispatch rules to dispatch certain responses, okay, when we're buying an item. So essentially, I could have an end-to-end test where I'm interacting with both live services, maybe services that have been built and are in a pre-production environment, and we want to run some tests, maybe some virtual services that are sitting on ServiceV. We can create checkpoints and assertions to validate the responses are correct, the same as we would do from SoapUI as well. So essentially, to me, it doesn't really matter if I'm interacting with a virtual service or a live service, as long as it's obviously built correctly and built to the needs of the company to satisfy until that actual service is developed. So I hope that answers your question.
What about downtime?
Yeah, I love.
What about downtime? I
love a bit of downtime in the evening after a busy day.
So you're asking about how do we simulate downtime, or what happens if the virtual services go down? Maybe if you could be a little bit more specific. We're happy to talk about that a little bit more.
Is the virtualization tool free as well? It's not. I mean, if you have a SoapUI Pro license or a LoadUI Pro license, you get base functionality of the other tools within the Ready API platform. However, if you want to use the full functionality of ServiceV, you would need a ServiceV Pro license. So, as an example, we would work with companies where you might have, let's say 5 to 10 people who are managing and creating these virtual services. They're building them. They would need licenses to do that. Once those services are deployed to Vert Server, then those APIs can be accessed and interacted with by anyone who has access to Vert Server. They don't need a ServiceV Pro license. They don't even need to use SoapUI Pro client if they don't want it. They can pretty much use whatever they want to interact with those services once they're deployed.
That's it. So we're coming up to the top of the hour. I wonder, are there any? There's no more polls.
Not really. Just maybe one other thing coming through. So from an automation perspective, so everything we did here, we built the services in virtual service in ServiceV. Once those services are deployed, and we've integrated our projects with our source control tools, maybe in Swagger Hub, we're pushing our API definition and our generated code to repositories in Git as well. Yeah. We can automate pretty much all of this, and build it into the workflows within our organization. So that, that could be with the use of integrations, with plugins into Jenkins and things like that if we want to run continuous integration. Obviously our source control tools as well. And there's command line runners for all the tools. So although we're building the stuff in the IDE, once things are built and developed, then we can automate those into different workflows.
Absolutely, and just for reference, there, I'll put a link into the group chat, just for more information about our command line runners. So if you the key thing with automation from these tools are the command line runners, and that's basically how you run all this stuff. Whether it's a virtual service or a functional test or a performance test, you can run all of this without going through the UI. So anyone who wants to learn a bit more about that, certainly take a look at that link.
Okay, 2 questions coming through. I'm going to answer them really quickly. How did you How did you create other server than localhost? So ServiceV will allow me to run my virtual services on localhost. Virt server then can be anywhere, right? So I would need to use Virt server if I want to share the virtual services that I've created locally.
Exactly. Yeah.
Okay. Another question coming through here as well. Is there a mechanism to automatically write the API skeleton in a particular language? For example, C# and then the developer just write the methods and bodies. Absolutely. Yeah. So CodeGen in Swagger Hub will allow me, if we're going with a design first perspective, I design my API, it gets signed off. Maybe we've role-based access control that controls that sign off in collaboration within Swagger Hub. Then I can auto-generate my client SDKs or my server code, push that to a branch or repository or whatever. My developers can pull that code in and start writing the methods, etc. Hopefully that
you should be able to just see that now. Is that from a Swagger Hub point of view? If you want to generate some skeleton code, there's an export option in the top right-hand side of the screen, and you can generate your client-side or your server-side code there.
Yeah. Question as well. Would you make a demo of switching between virtual APIs and those already implemented on AWS API Gateway, Azure, IBM? We can certainly do that. And what we're going to do, I think, for our next session is we're going to actually build something that sits on AWS. Mm-hmm. And then have a more detailed maybe demonstration of that. So that's kind of what we're thinking about doing for the next one, which should get into the weeds a little bit more.
Yeah, exactly. And, if that is something that you'd like to see, if you want us to take a more focused look at anything, or if there's something specific you'd like to see, certainly get in touch with us or your account manager or customers at smartbear.com, and we'd always be more than happy to arrange a demo where you can specify an agenda and we'll put together whatever it is that you want to see. Okay, so we're 2 minutes past 11 now, so I think we will leave it there. So then I think all that's left to be said is thanks to everyone who joined. I hope you found it useful. I hope it was worth getting through all those statistics to get hands-on with the tools by the end of the session. And I hope we were able to answer some of your questions. So Ronan, thanks a million for helping out with the Q&A and the questions. And thanks everybody for joining in. And we hope to see you again on one of these sessions soon. So bye for now. Have a great day.